Alright, so welcome back. In this video we're going to go ahead and discuss something called the remainder theorem. And so what is the remainder theorem? Well, rather than writing it out and just kind of reading it to you, I'm going to go ahead and show you through an example. So here we have example number 2, and it says given f of x, and so f of x is equal to x to the 4th plus 11. I'd like you to find f of 1. Now, if you think back to the sections that we've covered, typically what you would do is say, okay, well this right here is my x, and so wherever I have an x in my function, I would just replace it with 1. And we would go about solving this problem in this manner. So we would say, okay, well f of 1 is simply just equal to something to the 4th. Okay, well something's going to get replaced with 1, so x is getting replaced with 1 there. So it's going to be 1 to the 4th plus 11. And so again, 1 to the 4th is just 1, and then 1 plus 11, we would get just the answer 12. But what if this was a little bit more complicated? Like what if I asked you to find, well, find f of 80. Well, you really don't want to do 80 to the 4th power and evaluate that and then add 11 to it. So what I'm going to do is I'm going to try doing synthetic division, and I just want to see what's going to happen. So if I do synthetic division with f of x here, the highest power that I have is x to the 4th. So remember that I said you have to have all the powers. So if the highest power is 4, then I have to have the power of 3, the power of 2, the power of 1, and the power of 0. And if I look at this function here, it looks like I'm missing the power of 3, I'm missing the power of 2, and the power of 1. And so what I'm going to go ahead and do is just fill this in. So just remember, we can go ahead and add 0x to the 3rd. We can even add a 0x squared, and we can add a 0x. I mean, these are just technically all zeros, so they really don't matter, and it's the same problem as x to the 4th plus 11. So what I'm going to go ahead and do is synthetic division, and so let me go ahead and set that up. Remember, it looks something like this. We're going to make a line going down and then a line to the right. And again, I'm going to go ahead and fill up the first row with these numbers, the coefficient of these numbers here. So the coefficient for x to the 4th is just 1. And then remember, after that we need x to the 3rd. Well, the coefficient for x to the 3rd is just 0. The coefficient for x squared is also a 0. The coefficient for just x is also a 0. And then the number at the very end after x is just 11. Okay, and there's our function f of x. Now what I'd like you to do is, instead of thinking about x being 1, let's think about this as our k value. In other words, k is equal to 1 for us. And just remember that the divisor, when we divide, it's in the form of x minus k. So this value here, this 1, is going to go outside this box here that we've created. Now let's go ahead and perform our synthetic division. So again, I'll take this step by step. Just remember that the first step is to drop down the 1, so we're going to drop down 1, and then we multiply. 1 times 1 is just 1, and then we add 0 plus 1, well that's just 1. And again, we keep multiplying. 1 times 1 is another 1, is another 1, and then 0 plus 1 again is another 1, 1 times 1 is another 1, and 0 plus 1 is another 1, and it looks like we're getting a bunch of 1s, but then here we have 1 times 1 is 1, and then 11 plus 1 is 12. And so if we think about this, so we think about what we have, this number at the very end is known as our remainder. And we covered this in the previous video. This here is our remainder. This part right here is known as the quotient. But for this problem, we're not really interested in the quotient. What we're interested in is the remainder. And if you notice, the remainder is exactly the same number that we get when we plug the value of 1 into the function itself. And so what am I getting at? Well, the remainder theorem says this. It says, well, if you're asked to find f of k, if you have a polynomial, and if you divide it by x minus k, that's equivalent to saying that the remainder is equal to f of k. In other words, if I ask you to find f of something, Well, you can simply plug it into the function and go about it the old way that we were doing it, or you can do synthetic division with it, and whatever you get as your remainder, that is your f of k. So if I got 12 here, what I could say is, oh, okay, so then that means that f of 1 is equal to 12. And so when we look at part B in this example here, again, I'm asked to find f of 5 using synthetic division. In other words, I don't want to do this. I don't want to say f of 5 is equal to 5 to the 4th power plus 11. I don't want to plug into the function, because who wants to do 5 times 5 times 5 times 5? I sure don't, and I'm sure you don't either. But I could definitely just do synthetic division with 5, and so that's exactly what I'm going to do, and it's going to look like this. Again, remember the coefficients were 1 for x cubed, x to the 4th, 0 for x cubed, 0 for x squared, 0 for x, and then we had 11. And if I just, again, go through the motion here, so I'm going to drop down the 1. 1 times 5 is 5. 0 plus 5 is 5. 5 times 5 is 25. 0 plus 25 is 25. 25 times 5. Let me just get out a calculator just to make sure that I don't make any silly mistakes, but I'm pretty confident in saying that this is 125. 125 times 4 is 100, and then 25 more is 125. Here I'm going to have 125. This is where I wanted my calculator just to double check, but 125 times 5, we end up with 625, and then 625 plus 11. 625 plus 11 is 636, and just remember this is your remainder. It is safe to say that f of 5 is therefore equal to your remainder, which is 636. Now, if you were to go about doing it the old way, the way we would do it if we were just evaluating a function, 5 to the 4th power is 5 times 5, that is 25, times another 5, that's going to give us, let's see here, where were we? 5 times 5 is 25, times another 5, we're going to get 125, times another 5, we're going to get 625. So if you input that in your calculator, you get 625 plus 11, and 625 plus 11 is simply 636. And so that wasn't too bad to do, but just imagine if you had a longer or more in-depth polynomial where you had to do more plugging in and more evaluating. It just becomes a lot more tedious to do. So if you're asked to find or evaluate a function using the remainder theorem, you can simply just do synthetic division, and whatever your remainder is, that would be your answer.